Okay, so again, let's write out this fundamental So for pipes in series, right, after you've calculated minor loss coefficients, after you've done with those minor losses, you turn them into effective lengths. So some of these i's are actually effective lengths. So I should keep that n plus m, where I have m minor losses and n major losses. So some of these L's are actually effective lengths that you've previously done calculations. You'll end up at this equation, right? So now you can understand some of these types of questions you have. You could have the type of problem saying, right, given which would be what? All the pipe dimensions would be, I know the set of all the pipe dimensions. I know the set of all the lengths, right? Of course you do, because the minor losses you've turned into these lengths. What else? You know all the roughness values, right? And you know the required flow rate, right? So here's one type of problem, right? Given all these pipe dimensions, calculate, right? Find the head loss. That's the easiest one for head loss problems in pipes, because that's just straight up calculations, right? All you need to do is just calculate this monstrosity in a computer, right? That's nothing more than just, well, this is just equal to an effective resistance of the system times that, right? This resistance is coming from summing up all of your major and all of your minor losses, or it's coming from all the majors, calculating effective resistances, effective lengths for minor losses, and then you just get this nice simple expression. So that's the easiest type of problem that we can solve given the things we have. And I mentioned earlier, you can have another type of problem, right? Where you're given a head loss to begin with, and some amount of pipes dimensions aren't known. So let's just kind of go with that, right? This is a pretty bad one. Let's say this is just set notation. So I'm saying, given that I know the head loss, I know the flow rate, I know all the materials of the pipes, determine, right, all of the diameters. So that's where I was talking about that this doesn't really make sense, but because there are many solutions. There are an infinite number of solutions that can solve this problem. Because all you need to do, since I know this value and I know this value, and I just don't know what these values here are, you're just trying to find a set of numbers that make this equation true. Right? I guess I don't know why. Keep it the same. Okay. Right. So that's the idea of find all these diameters. I only have the one equation, so I actually can't determine that. But you're just trying to satisfy this equation now. So there could be many, many numbers that do that is the issue. So then it becomes about making like reasonable guesses on what they are. And then you can iterate to maybe like the closest solution that you'd have. Right, so you could make one of these diameters like infinite and it would kill off one of the terms and I could have another right diameter. Since it's to the 5th power, if I can pick any numbers I want, this number, if I could turn it into like 8,000 feet, and then I could still figure out what the rest of them are. So that's this idea of these iterative techniques where you kind of start with a guess of these values of where you want them to be, and then you would like iterate to like the closest true solution, because there are an infinite number of solutions to trying to solve this. I have one equation and you're asking me to solve for n plus m unknowns. So, there are many ways that we have to actually calculate something like this. There are iterative techniques. You can throw this into something with like MATLAB or an optimization solver or fsolve, and then you could put fmincon is on MATLAB to solve this as well, because like there are some obvious constraints about the diameters that we want, right? So just one constraint for this is sort of solve this problem. Find me n plus m diameters that make this equation true. But you could also say subject constraint that I want all of my diameters, they definitely have to be positive. In fact, you can do better. You can do like, I need them to be between subject to this, or find me m diameters, but this has to be true. Right? And that really narrows the solution space so that if you throw it into any solver, you would get the most reasonable solution. Not doing this, not doing this, I could give you a solution right now. I'll make all but n plus m minus 1 diameters infinite. That kills the rest of them. Then I just have to solve for one diameter. But of course, we can't make an infinite diameter pipe to run fluid through. So now I'll tell you the process of how you would create iterations to figure out these diameters and these types of problems of pipe sizing. It seems weird that it would work, but it does.